Okay, so here we go. First. The sample space of a chance process is the set of all possible outcomes. And we say a probability model is a description of some chance process that consists of two parts. The sample space, all possible outcomes, and then the probability associated with each of those outcomes. So let's look at an example. Imagine flipping a coin 3 times. Give a probability model for this chance process. Okay, so how many different outcomes are there if I flip a coin? There's heads and there's tails. How many times am I flipping? So I've got 2 raised to the 3rd power, which is 8. So there are 8 different outcomes. They all have the same probability. In this case, it would be 1 out of 8, right? But let's list them. We've got heads, heads, heads. We've got heads, heads, tails. Heads, tails, heads. Heads, tails, tails. Tails, tails, tails. Tails, tails, heads. Tails, heads, tails. And then tails, heads, heads. That is all 8 possibilities. Yes? So we say an event is any collection of outcomes from some chance process. It is a subset of the sample space. Events are usually designated by capital letters, A, B, and C, etc. When finding the probability of an event, we will write it like this: the probability of A. Okay, so this says find the probability of each. Event A is getting a 2 or more heads in 3 flips of a coin. What would this probability be? How many outcomes have 2 or more heads? There's 4, right? Out of the total of 8. So this would be 4 out of 8. Event B is getting no heads in 3 flips of a coin. So how many outcomes have no heads? 1 out of 8. Event C is getting at least 1 head in 3 flips of a coin. That would be 7 out of 8, because 7 of those events have at least 1 head. And then finally here it says, what is the probability of getting 2 or more heads or no heads? The probability of A or B with no outcomes in common. So what's the probability of 2 or more heads? 4 out of 8. And so what's the probability of no heads? 1 out of 8. And so we are going to add those probabilities together. The probability of getting 2 or more heads or no heads would be these 2 fractions added together, which is 5 out of 8. Okay, so we're going through probability rules today. So there are lots of different rules. Let's go through them. The probability of A is blank or blank for any event A. What goes in the blank? What numbers go in the blank? Probability must be between 0 and 1 inclusive. If S is the sample space in a probability model, then the probability of S is, what's the probability of everything in the sample space? Must be 1. And we say the sum of the probabilities for all possible outcomes must be exactly 1. Okay, so let's look at this probability model for grades in AP Stats. We have the grades A, B, or C. We have the probabilities associated with it, 0.2, 0.7, 0.1. Nobody fails in here. We're all above average. Okay, is this a legitimate? That was a little funny, right? Is this a legitimate probability model? Well, are the probabilities between 0 and 1? Yes. Is the sum of all the different probabilities added together equal to 1? Yes. Therefore, the total sample space is 1. And this is legitimate. Okay, and so then we have the complement. The complement of any event A is the event that A does not occur. And it's written as A with this superscript, C. Okay, so the complement rule states that the probability of A complement is going to be 1 minus the probability of A. So if the probability that it's going to rain today is 0.6, then what is the complement of that? Will be 1 minus 0.6, which is 0.4 or 40%. Okay, turn the page. And let's define some more terms. 2 events, A and B, we say they are disjoint or mutually exclusive. If they have no outcomes in common and so can never occur simultaneously. If A and B are mutually exclusive, then the probability of A or B, also written like this, the probability of A union B is the probability of A plus the probability of B. And this is called the addition rule for disjoint or mutually exclusive events. Well, we already looked at this rule. Right? Right, because look back. Is it possible to get 2 or more heads or no heads at the same time? No, so those 2 events are disjoint or mutually exclusive. And so to find the probability for 2 mutually exclusive events, we add the probability of A plus the probability of B. This is called the addition rule for mutually exclusive events. Okay, and so finally, if 2 events are mutually exclusive, then the probability of A and B, this is the intersection. The probability of those 2 events has to be 0. Because it's impossible if they are mutually exclusive. And so the Venn diagram looks like this. I've got my sample space with the rectangle. I've got the probability of A, probability of B, and there's no overlap between those 2 things. All right, and so if all outcomes in the sample space are equally likely, the probability that the event A occurs can be found by using this. We take the number of outcomes for event A divided by the total. And that's also what we did on the first. The probability of getting no heads, we look at the total number of outcomes that have no heads, which was 1, and then divide that by the total number of outcomes, which was 8. Okay. Questions for me up to this point? Well, stand up for me. we have the results of the 2013 AP Stats exam. So we have the scores 1, 2, 3, 4, and 5, and we have the probabilities associated with those scores. These are roughly the same every year. It changes slightly, okay, based on a number of factors, right? But how many students take the exam, how well they did, etc. But notice about 24% scored a 1 that year, about 19% scored 2s, almost 25% made a 3, little over 20% made 4s, and then about 12.5% scored 5s. Of course, all of us are going to score a 5, right? Because we're going to do our homework, study, work hard, especially in the second semester, listen to Newhouse and do what he tells you to do, right? So we're to make a 5. Okay. But part A says show that this is a legitimate probability model. Are all the probabilities between 0 and 1? Yes. Probabilities between 0 and 1. Yes. Is the sum of all the outcomes equal to 1? They are. Okay, I'll save us a little time. Sum equals 1 as well. So this is legit. Well, part B says find the probability that a randomly selected student who took the 2013 AP Stats exam scored a 3 or better. So how are we going to do that? Well, first, are the events mutually exclusive? Yes, because we're not going to score a 3 and a 4 at the same time. And so if we want to find the probability that they scored 3 or better, we're going to use the addition rule and add them together. So 0.249 plus 0.202 plus 0.126. This will give us the passing rate for 2013 on a national scale. So take your little calculator, add those up, and we get 0.577. Okay, meaning that approximately 58% of the students who took the 2013 AP Stats exam passed the exam with 3 or better. Okay. Our average will be much higher, right? So here's a quick little check your understanding. We'll just go through this quickly. We're going to let A be the person has a cholesterol level of 240 milligrams per deciliter or above, which is defined as high cholesterol. B will be the person has a cholesterol level of 200 to 239, which we're going to define as borderline high cholesterol. According to the American Heart Association, the probability of A is 0.16. The probability of B is 0.29. Explain why events A and B are mutually exclusive. Yes?
You can't have high cholesterol and borderline.
At the same time, right? So you cannot have high cholesterol and borderline at the same time. So say in plain language what the event A or B is. And then what is the probability of A or B? Well, in plain language, it was B. You have either high cholesterol or borderline high cholesterol, right? In plain language, you either have high or borderline high cholesterol. And what is that probability? Since these two events are mutually exclusive, we are going to add them together. So we got 0.16 plus 0.29, which is 0.45. Meaning, that's not good, right? Approximately 45% of adults have high or borderline high cholesterol. Well, if C is the event that the person chosen has normal cholesterol below 200, what is the probability of C? How would we find that? 1 minus 0.45, which is 55%. And so this is an example of the, what rule is this? Complement rule. Okay, so a blank can display the sample space in a way that makes probability calculations easier. This is called a two-way table. A two-way table. So here we go. What is the relationship between educational achievement and home ownership? A random sample of 500 US adults was selected. Each member of the sample was identified as high school graduate or not, and as homeowner or not. The two-way table displays the data. Okay, so we've got homeowners, right, here and here, or not a homeowner, and we've got high school graduate, not a high school graduate, and then the totals. Suppose we choose a member of the sample at random. Find the probability that the member is a high school graduate. So we're going to look at the total number of high school graduates, which is 310 out of the total in the sample, which was 500, which is approximately, okay, 62%. Whew, it's not good, right? Are these is this data accurate? I mean, it depends on how you define high school graduate, right? Are we counting GEDs? That type of thing? Or are we looking at only 18-year-olds? Or are we giving a little bit of grace there? We're going to look at all 24-year-olds. Do they have a high school diploma or equivalency? Something like that, okay? So the answer to that is it depends, right? But that's kind of beyond the scope of what we're doing right now. Look at part B. What is the probability that they are a high school graduate and they own a home? Okay, so that's going to be this number right here. So they're a high school graduate. They're also a homeowner. So that probability is going to be 221 out of 500. So let's look at this. And let me preface this by saying I'm going to work this the wrong way so that you can see why it's wrong. What is the probability that they are a high school graduate or they own a home? So the probability that they are a high school graduate is 310 out of 500. What is the probability that they own a home? Probability of H is going to be the total number of homeowners, 340 out of 500. Okay, so if I add these two things together, I've got 310 plus 340 out of 500, which gives me 650 out of 500. And is that a reasonable answer? No, it is not. Why? What is wrong? Exactly. these events are not mutually exclusive. So if we do it this way, we're going to count certain people 2 times. Okay, so go back to this. The addition rule only applies, where's it at? Right here. The addition rule is for disjoint or mutually exclusive events. If you want to find the probability of A or B and the events are not mutually exclusive, then you must do this. Okay, it is the probability of A plus the probability of B minus the probability of A and B. That is for the probability of A or B if they are not mutually exclusive. It may also be written using symbols, okay? This is union. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A, and this is called intersection. Okay, so this is what I call the Queen of Hearts rule. So I have a standard deck of cards. How many cards are in a standard deck? 52. So what is the probability that I select a queen or a heart? So let's define A as the probability of selecting a queen. How many queens are in a standard deck? There are 4, because there are 4 suits, right? So this would be 4 out of 52. And so the probability of B is going to be the probability that you select a heart. How many hearts are there? There's 4 different suits. There's 52 cards. 52 divided by 4 is 13. So there are 13 out of 52 hearts. Okay, so if I do the probability of A plus the probability of B, 4 out of 52 plus 13 out of 52. But now what's wrong with this as it is right now? I've counted the Queen of Hearts twice, 1 right here in the queen and 1 right here in the heart. So I must subtract the intersection. How many Queen of Hearts are there? There's 1 out of 52. So this probability would be 4 plus 13 minus 1. So 16 out of 52. Okay, so 2 different possibilities. If the events are mutually exclusive and it asks, what's the probability of this or that? You add. If they are mutually exclusive, though, it's the Queen of Hearts rule. I'll take the probability of A plus the probability of B minus the intersection of A and B. Because if you are playing with the Queen of Hearts, you know that it's not always smart. The Joker ain't the only fool who will do anything for you. I mean, that's a little funny, right? I mean, I'm sorry, do we not listen to any music outside of, I don't know, like Taylor Swift or something? We got nothing? You're just like, all right, I'll stop. I won't tell any more dad jokes. I will just move on. Sorry, forget I ever mentioned it. Let's move on. Looking back at part C, correctly calculate the probability of G or H. Go, do that for me. Check with your neighbor there, make sure they got it right. Probability of G. So we've got 310 over 500 plus 340 over 500 minus, what is the intersection of graduates with a homeowner? 221, right? So 221 out of 500. So we're gonna add those two things together and then subtract, and we should get 429 out of 500. Since they are not mutually exclusive. All right. Here is the two-way table summarizing the relationship between educational status and home ownership from the previous example. All right, we're going to look at the two-way table in symbols, which you are responsible for, right? And that is also associated with the Venn diagram here. So in the intersection of two circles, so they are a graduate and they own a home, and we write this as G intersection H. How many are in this category? It's the intersection, so 221. Inside circle G, outside circle H. Graduate, and they do not own a home. So look, here's how we write this. It's G intersection H complement. Okay, so what is G intersection H complement? Okay, that means I'm in the G circle, but not in the H circle. So that would be 89. Not a graduate, but own a home. So G complement intersection H, that's going to be the 119. And then G complement intersection H complement. I'm in neither one of the circles, but I'm still inside the sample space. That would be 71. Okay, so we're going to do like one more example here, but you need to be familiar with the Venn diagram and the symbols. Okay, so I have sample space, inside the circles, the probability of A, outside would be A complement. Here, they're mutually exclusive, inside the sample space, S, inside the rectangle, and then I have A and B, but there's no intersection. Okay, so this right here, if it's U, then that is union. If it's the upside down U, then that is the intersection. Okay, so A intersection B is going to be this area right here, shared by A and B. A union B is going to be the two green circles there, okay, A or B. All right, so let's look at one more example here. It's a little dated, but it will serve for our purposes. So according to the National Center of Health Statistics, in December of 2012, 60% of US households had a traditional landline telephone, 89% of households had cell phones, and 51% had both. Suppose we randomly selected a household in December of 2012. Part A says make a two-way table that displays the same sample space of this chance process. Okay, just so we're on the same page. Everybody know what a landline is? That phone right over there. Okay, so like I said, it's a little dated. Those numbers would obviously change now because lots of people did not have landlines, but we're going to make a two-way table. All right, so let's make a two-way table. We got landline. We've got no landline. And then we've got cell. We've got no cell. And then we're gonna have the totals. This is the key to working these problems. Start with the intersection. Start with the intersection. Start with the intersection. What do I mean by that? In the context of this problem, how many had both? 51% had a cell phone and a landline. Okay, so the intersection is going to be this one right here. That is 0.51. Start with the intersection. Okay, so now let's go this way across. What total percentage had landlines? 60%. So the total for landlines was 0.6. And so how many go right here with the no cell? It would be 0.6 minus 0.51, which is 0.09. How many, what was the total percentage of cell phones? 89%. So this, looking this way, look up here. This column, the total for cell phone, that must be 0.89. So what does this have to be? 0.89 minus 0.51, which is 38%. What's the total of everything? Has to be 1. Okay, so what's this total? Looking at this column, this has to be 0.4. This has to be, careful, this way right here. This one right here is 0.11. Therefore, 0.38 to 0.4 or 0.09 to 0.11 must be 0.02. So now let's do the Venn diagram. It's the same process. All right. Gotta have a sample space. I'm going to let L equal the probability that it's a landline, C equal the probability that it's a cell. Okay. This is going to be L. This is going to be C. Where do we start? The intersection. So what goes in the middle there? 0.51. Not drawn to scale, right? So now look up here. What's the total probability that had landlines? The total. It was 60%. So look up here. Just this circle. I'm just looking at the L circle. There's already 51% inside that circle. So what is in the circle but not in the intersection? It would have to be 9%, not 0.9, but 0.09. And now, what was the total probability that had a cell phone? It was 89%. There's already 51% inside the circle. So there's got to be 38% to make the total 89%. Okay. And so then if I add these up, 0.09 plus 0.51 plus 0.38, what do I get? I get what? 0.98. So what, and it's got to be 100% total. So what goes outside the two circles, but inside the sample space? 0.02. Okay, and so now we can answer these quickly. Find the probability that a household has at least one of the two types of phones. A landline, a cell, or both. Okay, well, look at it. What's the answer? 98%, right? We can see that from the Venn diagram. But in symbol, let's write it out in symbols. We want the probability of what? L union C. All right. And mathematically, are the events mutually exclusive? No, because you can have both. Therefore, this is Queen of Hearts rule. Okay, which would be probability of L plus probability of C minus the probability of L union C. Okay, and so we can look at the Venn diagram and work it out, but it's helpful to look at the rule here. What's the probability of L? What's the probability they have a landline? 0.6. What's the probability that they have a cell? 0.89. Minus the intersection, and what's the intersection? Intersection is 0.51. So 0.6 plus 0.89 minus 0.51 equals 98%. It works. Find the probability that the household has a cell phone only. So I want the probability only cell phone. Okay. This would be the probability. Let's write it in symbols. How would I write it in symbols? It's not L, but it's what? It's L complement. No landline. Intersected with C. Okay, so look at this. Make sure that you understand this. All right. I want the probability that they do not have a landline. So L complement intersected with a cell phone. Okay. And so what is that probability? Look at it. Look at the Venn diagram. It's 0.38. Yes.
Could you swap it and say C?
Other way around? That's fine.